So heat is a measure of the size of the particles and how much thermal energy they have. So heat is an actual measure of energy. Now temperature is simply a measure of the average kinetic energy of a sample. So anytime you see the word temperature, you're going to cross it out and you're going to write average kinetic energy. And likewise, if you ever see the word average kinetic energy, you're going to cross that out and you're going to write temperature. Okay, so these words are interchangeable. Keep that in mind. We're going to be dealing with heat or thermal energy. We're going to be dealing with that in the next unit. Okay, right now I have two different samples. I have a sample of oxygen gas at STP, and I have a sample of solid water or ice at STP. Now, these particles both have exactly the same average kinetic energy. And the reason for that is because both of these samples are at the same temperature. Average kinetic energy is the same thing as temperature. Okay? So if I ask you for the average kinetic energy, pay attention to the temperature. They both have exactly the same temperature, which is 273 Kelvin. All right, the last thing that I'm going to show you is I'm going to talk about a heating curve. And this is basically what you do, or this shows you exactly what's happening to a particle when it's heated from a solid to a gas. So I'm going to use water as this example. And I'm going to start out, first of all, water is ice format first. All right, so I'm going to start out at point A, and I'm going to heat this sample of pure water. It is in the solid form. So from A to B, I start out in a solid. So I'm going to draw a particle diagram for a solid. And what's happening between A and B is this is one phase. It is the solid phase, and it's only solid. So this solid is heating up from a cold temperature to a warmer temperature. Now at point B, something starts happening. This solid starts becoming a liquid. So what's happening is it's going from the solid and it's starting to melt. So this process right here is considered melting. So starting at point B, this solid is starting to change into the liquid form. So this is considered melting. Once we reach point C, the temperature starts increasing. And this is in the liquid phase. So this phase, it's simply 1, 2, 3, 4, 5, 6, 7, 8, 9. This is liquid only. Again, solid only. This is melting. This is liquid only until we get to point D, where we're increasing our temperature. And finally, here, we're starting to have some liquid phase. And then we're also having some that is in the gas phase. So this is considered boiling. And then finally, from point E and onward up to F and above, this is the gas phase where it is it's only a gas. So what is happening? How do we interpret this graph? First of all, we're going to be doing a lab about this, and you're going to be observing how this graph would actually look in real life. So what happens? We start out when anything is increasing, going up in the y-axis, it's actually heating. So all the energy right here, so this energy is for changing temperature. This energy from A to B is changing the temperature. So that is increasing the average kinetic energy. As you go between B and C, if you notice, the temperature isn't changing because average kinetic energy is remaining the same. So this is a change in potential energy. Potential energy is the energy of position. You probably learned that this has more potential energy than this, and kinetic energy is when something's actually moving. But basically, it's rearranging the particles. So it's changing the energy of the position of these particles. If you notice, these particles are just increasing in their average kinetic energy. These particles are increasing their shape or changing their shape. Now if I look up here, again, average kinetic energy, or AKE, is increasing. And right here, we're just doing a phase change. And again, up here, the temperature is increasing. So, you can see all that. When all is said and done, this graph is showing temperature, phase, temperature, phase, temperature. It's pretty self-explanatory. You're gonna get a little bit of practice. Speaking of which, look at that. Good luck. What in the hell? That was a long ass.